The Big Bang happened almost 14 billion years ago. It was the first event in the history of our universe, and we can still see the effects of this sudden and violent growth of the universe. Cosmic microwave background radiation shows tiny changes in temperature and density as clumps of bright blue and purple. Welcome back to another space video. Today we'll be taking a look at the James Webb Space Telescope and the 5 biggest mysteries in astronomy history this telescope will help us understand. So if you enjoy our content, make sure to subscribe to our channel. In the 1990s, NASA's Cosmic Background Explorer satellite took the first picture of what the early universe looked like 400,000 years after the Big Bang. In 2006, the Nobel Prize in Physics was given to the scientists who led this work. John Mather, who won the Nobel Prize, is in charge of a new project at NASA's Goddard Space Flight Center. This project will tell us what happened in the next chapter of the early universe. The James Webb Space Telescope is the biggest and most powerful space telescope ever made. It promises to look back in time and space to see how the first stars and galaxies formed from hot, dense clumps of gas and dust. Dr. Mather, who is in charge of the James Webb Space Telescope project, says, "I'm hoping that it will tell us about the beginning of everything. It would be interesting if all we did was confirm the story we already knew. But I think it's also possible that there's something that we haven't guessed out there yet to be discovered. From the beginning of the universe to the present, here are the 5 big questions that astronomers hope the James Webb Space Telescope will answer. Number 1. How did the first stars and galaxies look? About 300,000 years ago, the universe was a hot fog of energy and plasma that light couldn't get through. We call this the dark age of the universe. As the universe grew and cooled over the next billion years, the first stars pumped out hydrogen and helium, which changed the plasma around them. Dr. Mather says that the first stars would have been very different from the stars we see now. The prediction is that the first stars were hundreds of times as massive as the Sun, and that they would burn out in a few million years or blow up into supernova, or collapse into black holes, or maybe both. But we've never been able to see how the first galaxies and stars came to be. Amber Strawn, an astrophysicist at the Goddard Space Flight Center and the James Webb Space Telescope's deputy project scientist, says, "We're missing the very first part of the puzzle. One of the big questions is how we go from the dark ages, the dark part of the universe, to the universe we live in today, which is filled with light. We've been able to see galaxies that were around between 400 million and 800 million years after the Big Bang." The Hubble Space Telescope took a famous picture of these galaxies called the Ultra Deep Field, which took 2 weeks to make. There are very few rare objects in that picture that go back about that far, Dr. Mather says. The new James Webb Space Telescope is so powerful that it should be able to look further back in time and make an image of the first galaxies in just a few hours. We will be able to see much closer to the Big Bang with the Webb telescope, maybe within 100 million years, Dr. Mather says. Seeing this far back might also help us figure out another mystery. Number 2. Why do galaxies have supermassive black holes in the middle? Every galaxy has a supermassive black hole in its center that is millions to billions of times the mass of our Sun. In 2019, we took the first picture of the gas swirling around a black hole at the center of the M87 galaxy that is 6.5 billion times the mass of the Sun. But we don't know how black holes and other monsters like them were made. One way that it could happen is that the first generation of stars made small black holes, and then those black holes started to swallow up either other stars or gaseous material, or dark matter, or whatever is out there to eat, Dr. Mather says. Gravitational waves, which are tiny ripples in the fabric of space-time, have shown us that this process is happening. Dr. Mather says that so far we've only seen gravitational waves from small objects with the mass of stars. So we don't know how they grow up to be millions and billions of times the mass of the Sun. Number 3. How do new stars appear in the Milky Way? A huge cloud of gas and dust called a nebula is where stars are born. Over time, the Hubble Space Telescope has taken amazing pictures of these places in the Milky Way where stars are born. Nebulas are so dusty that it's hard to see what's going on underneath the clouds. The Pillars of Creation in the Eagle Nebula is one of the most famous pictures taken by the Hubble Space Telescope. On the left side of the image, you can see how the pillars look in visible light. On the right, you can see how they look in a narrow range of infrared light. In the infrared range, the new James Webb Space Telescope will be even better. It should be able to see further into the dark spots in the image on the right. Dr. Strawn says the pictures will be beautiful. One of the great things about infrared light is it allows us to peer down into those dust clouds where stars and baby planets are forming. Number 4. Is there another planet like Earth out there? A little over 10 years ago, we only knew about the planets in our solar system. But since the Kepler Space Telescope and its successor, the Transiting Exoplanet Survey satellite, were made, we found more than 4,800 planets in orbit of stars that don't belong to us. Dr. Strawn says there are almost certainly more planets in the Milky Way than there are stars. Some of these planets are unlike anything else in our solar system. For example, sub-Neptunes are bigger than Earth, but smaller than Neptune. Other planets are about the same size as Earth and orbit their sun's habitable zone, which is where temperatures might be good enough for life to exist. For example, the TRAPPIST solar system is about 40 light-years away and has 7 planets that revolve around a dwarf star that is about 9% as heavy as our Sun. In theory, 3 of the 4 planets may have temperatures where water can form if they have an atmosphere. We don't even know if Earth-like planets have atmospheres, says Dr. Mather. Stars like TRAPPIST-1 have violent outbursts that could make the planets uninhabitable. Astronomers can tell if a planet has an atmosphere by looking at the chemical signature of light passing through gas as the planet passes in front of its star. Spectroscopy is a method for figuring out what molecules like water, carbon dioxide, and methane absorb light at certain wavelengths. But if a star is very small, then a planet the size of Earth absorbs a lot of its light, Dr. Mather says. At the moment, we can't do spectroscopy on our little Earth-like planets at all. With the James Webb Space Telescope, this is going to change. Astronomers plan to use its sensitive infrared spectrometers to do the first detailed study of the atmosphere of a planet in the habitable zone. The extra power of the spectrometer will also help find signs of possible life and support space missions much closer to Earth. Number 5. Could there be other life in our solar system? Scientist Galileo found Europa, a moon of Jupiter, in 1610. In the 1990s, the NASA Galileo spacecraft looked at Europa and found that its cracked, icy surface covered an ocean. And we discovered fairly recently that there are little jets of water that come out between the cracks in the ice, Dr. Mather says. This raises the question of whether or not this icy moon of Jupiter might have the right conditions for life. NASA wants to find out by sending a new spacecraft to Europa in the next 10 years to look at its surface and atmosphere. We are also going to watch Europa with the James Webb Space Telescope, Dr. Mather says. One of Saturn's moons, Titan, will also be looked at with the James Webb Space Telescope. The surface of Titan is cold enough that ethane and methane, which we use for fuel here on Earth, are liquid, Dr. Mather says. Titan has liquid rain, lakes, and even rivers on its surface, so its weather and geology are interesting. In 2034, NASA wants to send a mission to Titan. The Dragonfly rotocopter will make several trips around this icy moon to collect samples and look at different places. We will need the Webb to last a long time to really confirm those conditions on Titan, but we'll be watching it from as soon as we can. That's it for today's video. Make sure to leave a like and subscribe to our channel if you enjoyed this content. We hope to see you soon on a brand new update.